Welcome to Sprecher Schuh's Houston, Texas headquarters, and I'm Mike Flanagan. The video you are about to see tells the story of how the arc interruption techniques employed in Sprecher Schuh contactors reduces the arc time and the associated heat. Less arc and heat means the mass required to dissipate the heat during contact breaking can be reduced, thus a smaller device. Less arc on the precious metal of the contact tips means longer electrical life. If you've had questions about how IEC devices can be so much smaller than their NEMA counterparts and still have an average electrical life of 1 million operations and 10 million mechanical operations, you'll find this film interesting. Let's move into the lab and take a little closer look. The construction of Sprecher Schuh contactors incorporates a U-shaped current path rather than the straight in and out current path utilized by many of our competitors. As shown in the cutaway diagram, when the contacts are closed, the current flows in from the line through the U-shaped conductors, then through the movable contacts and out through a similar U-shaped current path to the load side. During opening, the right-hand rule of electromotive force results in an outward force, drawing the breaking arc away from the main contacts, as indicated here by the red arrows. There are 4 key elements of arc interruption shown in this diagram: guide rails, blast plates, arc horns, and arc laminations are commonly referred to as arc chutes. In order to understand the function of each element, let us examine what happens during a full load breaking arc. The arc starts between the stationary and movable contacts. The arc is then drawn to the guide rails due to the electromotive force set up by the U-shaped current path we talked about. The arc quickly jumps to the arc horns, and now the burning and pitting that occurs during breaking is off the current carrying precious metal. As the contacts continue to separate, the arc is drawn into the arc chamber, separating and quenching the arc, much the same as a circuit breaker operates. We have defined the function of the 4 elements of arc interruption diagrammatically so that you can see the function of each element in actual operation. We have a high-speed film showing the techniques in quenching an arc before it burns away precious contact material. You'll be able to see this clearly as we have filmed all the sequences at the same speed. Alternating current at 60 cycles per second with 2 zero crossovers per cycle means 120 zero crossovers per second, or in other words, 8 milliseconds per zero crossover. So the action has been significantly slowed for our viewing today. If you watch closely, you'll be able to see the arc restrike and die down as it passes through each peak and zero point. For today's test, we have selected a CA1 480 rated by UL at 420 full load amps open, 400 full load amps enclosed. Film sequence number 1 will be at 440 volts, 1,000 amperes at a 0.36 power factor to simulate a heavy inductive load. From this illustration of the test chamber, we will see the film sequence to follow. The Sprecher Schuh contactor uses none of the key elements to draw the arc away from the contacts. Please note that the arc grows, then diminishes. Each time it diminishes, the arc is at the zero crossover point. The arc will be extinguished in the 7th zero crossover. Sequence number 2 The voltage and current specifications will remain constant. Please note that our test current far exceeds the 400 amp UL rating. In sequence number 2, we will install arcing horns, guide rails, and blast plates, but without arc quenching laminations. Following this test chamber illustration, we will see the arc extinguished in the 6th zero crossover, or in 48 milliseconds. Note the violence of this sequence and the restrikes due to the absence of arc chutes. In sequence number 3, voltage and current will remain the same, but this time using arc laminations only. The arc will be quenched in the 5th zero crossover. As before, the action will follow this test chamber illustration. Note the difference in how the arc behaves compared to the previous sequences. Count the zero crossovers. There will be 5 this time. Still, the voltage and current will be held constant. In sequence number 4, we will add guide rails to the arc laminations. No arc horns or blast plates. The arc will be quenched in the 2nd zero crossover. The violence of the arc will be greatly diminished, interrupting the arc in the 2nd zero crossover, or 16 milliseconds. Expends the electrical energy in the arc chamber rather than on the precious metal of the contact tips. In sequence number 5, we'll keep the arc laminations, but omit guide rails and add arc horns and blast plates. The arc will be extinguished in the 2nd zero crossover. And our test chamber illustrates what we are about to see in the sequence to follow. The arc will be clearly broken without any significant wear on the contact tips. The arc will be quenched in 16 milliseconds. Electrical specifications are again the same. In this sequence, all 4 key elements of arc interruption will be utilized. The arc will be interrupted in the 1st zero crossover. Test chamber illustration is now complete, with arcing horns, blast plates, guide rails, and arc quenching laminations. This will illustrate the dynamic performance and dependability Sprecher Schuh offers, making 1 million electrical operations possible in a device smaller than our NEMA competitors. Remember, all these sequences are at the same slow motion speed, but watch closely, as 8 milliseconds is fast even in slow motion. In sequence number 7, we will turn up the current to 5,000 amperes, more than 12 times the UL rating. Power factor will be adjusted to 70% for this test. All 4 key elements of arc interruption will be employed. It will take only 2 zero crossovers. Our final test chamber is a performance challenge. Sprecher Schuh will not only take it, but will go ahead and place it on record with you, unlike many of our competitors. Let's take a look. You have now seen the four elements of arc interruption reduce the duration and damage of breaking full load current. Less arc means less heat. Less heat means less mass to dissipate the heat. This is one of the key reasons IEC devices can be so much smaller. The growing acceptance of IEC-type devices in a market previously dominated by NEMA-type devices gives users and specifiers positive alternatives in motor control selection. We hope you found our informal video interesting. Thank you.